Hi everyone. This video is about the key concepts in explaining the graph of the competitive and non-competitive inhibitors. We have learned that the competitive inhibitor will increase the Km of the reaction, but not the Vmax. On the other hand, non-competitive inhibitor will not affect the Km of the reaction, but it is going to decrease the Vmax of the reaction. So what is the reason behind this? Before going to the reason, we have to make it clear what is the Km. Km, also known as the Michaelis-Menten kinetics, is actually a measure. Yeah, it's a measure of the affinity of the enzyme for the substrate. So when an enzyme is, when a reaction is having the lower Km, that means that the enzyme is having greater affinity. Yeah, having greater affinity to the substrate. So in other words, the substrate is more likely to bind to the enzyme. They have higher chance and more likely to bind to the enzyme. So that is the Km means. So now we look back into the reaction. So the green color here is the enzyme, and the blue color one is the substrate. First thing first, we talk about the competitive inhibitor. Why the competitive inhibitor, when it's being added into the reaction, it will increase the Km. That means that make the substrate less likely, to bind to the enzyme. So I will use the red color to indicate the competitive inhibitor. Now let's say competitive inhibitor has been added. Hey, before adding the competitive inhibitor, the chances of the substrate to bind to the enzyme is 100%. Although the substrate will compete with each other to bind to the enzyme. But no matter what, no matter this substrate or this substrate or this substrate or this one bind to the enzyme, it is always the substrate bind to the enzyme. That means that it is always going to produce the product. So in that case, it will contribute to the rate of reaction. So that's why without the competitive inhibitor, the substrate will always bind to the enzyme. But now, after we have added the competitive inhibitor, we have learned in theory that the competitive inhibitor will compete with the substrate for the active site of the enzyme. So that means that these competitive inhibitor will compete together with the substrate. So let's say these 5 is going to compete to bind to the active site of this enzyme. Then that will mean that this enzyme will now only have 80% of chance to bind with the substrate. There are 20% of chance that it is going to bind with the competitive inhibitor. So because of this, it made the substrate less likely to bind to the enzyme, and thus it is increasing the Km. So how are we going to reverse the effect of this competitive inhibitor? Well, what we can do is we need to increase the number of the substrate. So when there is more substrate now, all of these will be competing. It will be competing with the for the active site. So in this case, the chances for the substrate to bind to the enzyme active site will now increase. So that's why we can reverse the effect of this competitive inhibitor by increasing the number of the substrate. So at the same time, that will also means that you will need higher concentration of the substrate in order to reach the original rate of reaction. So that's why this is what we can see in the graph here. When it is uninhibited, the Km is lower. In order to reach this rate of reaction, you only need lower concentration of the substrate. But with the competitive inhibitor, when you have added the competitive inhibitor, you will need higher substrate concentration. Then only then you can achieve the same rate of reaction. So lower concentration of the substrate indicate lower Km. So meaning that the enzyme is having higher affinity. Higher Km with the competitive inhibitor added, it will cause higher Km. So that will mean that the addition, when you add the competitive inhibitor into the reaction, it is going to increase the Km, meaning that it is lower down the affinity. It is lower down the chance of the substrate to bind to the enzyme active site. So with that, that is why competitive inhibitor will increase the Km. But the competitive inhibitor will not affect the Vmax of the reaction. Vmax will means that the maximum rate of reaction. So why the competitive inhibitor will not affect the Vmax? Well, the reason is because all the enzymes are still working. So as long as we increase more and more substrate, so as long as we increase more and more substrate, I will draw it. So let's say we increase more and more substrate, then that means that the chances of this substrate to bind with the active site will be higher and higher. So it will be, when we keep on increasing it, it will be close to 100% again. So that's why those reactions that has been added with the competitive inhibitor will still be able to achieve the Vmax. It will still be achieve the same Vmax of the reaction. It's just that in order to achieve the original maximum rate of reaction, the reaction with the competitive inhibitor will need way higher substrate concentration. So it is same like what we have mentioned just now. You need to add more and more substrate so that the chances of this enzyme to bind with the substrate is almost 100%. That in that case, yes, we will reduce the chance of this competitive inhibitor to bind with the active site. So by doing this, the reaction still can achieve the maximum rate. So because of this, the competitive inhibitor will increase the Km, but not the Vmax. On the other hand, non-competitive inhibitor will have no effect on the Km, but will reduce the Vmax of the reaction. So we will look at it. What is the reason of this? When the non-competitive inhibitor is being added, non-competitive inhibitor, I will change the shape. Still in red color, but maybe in a circle. When non-competitive inhibitor is being added, it will not compete with the substrate. Non-competitive inhibitor will directly go and bind to the allostatic site of the enzyme and shut the enzyme down. So that means that when I add the, let's say I add one non-competitive inhibitor, it will directly go and bind with the allostatic site and it will shut down this enzyme. So when the enzyme is shut down, let's say one enzyme can bind with one substrate to produce one product in 1 second. So that means that the rate of reaction would be 1 per second. So with 4 enzyme, originally, with 4 enzyme, it will be 4 per second. So that is the rate of reaction, the maximum rate of the reaction. But now we have added the non-competitive inhibitor. So that means that one enzyme has been shut down. So when one enzyme has been shut down, every second, only 3 substrate can bind to the enzyme and produce 3 products per second. So the rate of reaction has reduced from 4 per second to become 3 per second because one of the enzyme has been shut down by the non-competitive inhibitor. So that's why these non-competitive inhibitor will reduce the Vmax of the reaction. But non-competitive inhibitor has no effect on the Km of the enzyme. Why it has no effect on the Km? It's because they don't compete with the substrate. For those enzymes that are still working, the affinity to the substrate is still the same. It is still 100%. As long as when the substrate can bind to the enzyme, the chances for the substrate to bind to the enzyme is still 100%. So that's why it's not affecting the affinity or the chances of this substrate to bind to the enzyme. And because of this, the non-competitive inhibitor has no effect on the Km, but it will reduce the maximum velocity of the reaction. So these effect, we can see it in the graph as well. Those reactions that has been added with the non-competitive inhibitor will never come to the original Vmax. It will not come back to the original maximum velocity or maximum rate of reaction. It will be somewhere lower. So the reason is very simple, because the enzyme has been shut down. The non-competitive inhibitor is reducing the concentration of the enzyme. So because of this, the non-competitive inhibitor, the reaction will never reach the original Vmax. It will settle at the Vmax that is lower. So no matter how much substrate you add in, so with the increase of the substrate concentration, the Vmax will be always lower than the original one. It will not increase. The reason is because no matter how many substrate you add, you increase the concentration of the substrate, the number of the enzyme that's available is still the same. So that's why it will not increase the Vmax. So with that, that is all the key concepts that's important when we explain the graph of the competitive inhibitor and the non-competitive inhibitor.